Hello and a very good day. My name is Abhilash and I am from the AD Solutions team here at Manage Engine, and I will be your presenter for today. Now, before we go ahead and jump in and see what's in store for us, I would like to thank all of you for joining in. Thank you so much for taking out the time. Thank you so much for making the time out of your busy schedule to be a part of this webinar session. Now, before we go ahead and jump in, I would like to wish all of you a very happy and a very prosperous new year. And like always, since we're all working from home, just a quick audio and video check, because I want to make sure that everybody out here today are able to hear me well and are able to see the screen well. Right. So I'm quickly going to start off with an audio check. If you can hear my voice, if my voice is well and audible without any distortion or any breakage in the audio, can you please give me a confirmation using the chat window or the Q&A tab, please? Just say yes, just say okay, just say great, so I can confirm that my voice is reaching to you well and clear. Thank you, Marcus. Thank you so much for your response. I hope you can see the video well and clear as well. If you've got any issues with the audio or the video during the course of the webinar, just let me know using the chat window or the Q&A tab, and I'll do my best to fix the issue from my end. All right. Now, before we go ahead and jump in, I would like to tell you that the entire session, the entire 45 to 50 minute session that's going to happen right now is going to be recorded. And the recording will be sent to you on your email IDs probably within the next 1 or 2 days. So during the course of the webinar, if you've got any questions or if you have anything on your mind that you'd like to ask me, just drop in your questions or queries using the Q&A tab, and I promise I will get back to you either during the course of the webinar or during the last 10 to 15 minutes of the webinar session, which will be a dedicated Q&A session. Right? So with all the formalities out of the way, let's go ahead and jump in. And before we get started, I'd just like to remind you that I am working from home, and I'm sure most of you are as well. And if you have any audio or video difficulties, just let me know and I'll try and fix it from my end. All right, so let's jump in. The topic for today is identifying security misconfigurations that can lead to breaches. Right now, why did I choose to speak about this topic today? And what are the security misconfigurations that we will be discussing about today? Now, the whole reason I chose to speak about this topic today is because more often than not, the high profile breaches that happen, right? The high profile breaches that happen in organizations like Twitter or Microsoft, or even the most recent SolarWinds breach, right? Whenever such breaches happen, generally the news or the articles on the internet cover two things. The first thing is the scope of the breach, how much the breach has affected, or who the breach has affected, or how bad the aftermath of the breach was. But one thing the news channels or the articles or any investigative reports don't cover is the misconfigurations that led to the breach in the first place. Right? So that's going to be the idea of today's webinar. We will take a look at the most devastating breaches that have occurred in 2020 and also to some extent in 2021. And we will see the security misconfigurations that led to these breaches, or at least were a promotion factor or helped faster spread of these breaches. Right? So what do I mean by security misconfigurations? When I say security misconfiguration or a security mishap, I just mean that any organization that has implemented the security controls that they need, but has done so with errors, right? Has not done it properly, that could lead to a security misconfiguration. Any organization that has failed to implement sufficient security controls for a server or an application or a user could lead to a security misconfiguration as well, right? Misconfigurations on a network are extremely difficult to discover because misconfigurations can occur on a server or a user or an application. Misconfigurations can be caused by anyone. It could be a genuine mistake by an admin. It could be a mistake caused by a help desk technician or even a user who's got some kind of access to your IT environment. And the problem is, once external attackers or malicious or rogue inside users discover these misconfigurations, it's only a matter of time before they gain access to your network, right? So just redefining what the webinar today is about, just redefining the goal, we will be talking about the misconfigurations that led to the most devastating breaches in 2020. Right now, this will be speculation because most companies, they do not disclose why a breach happened or the misconfiguration that led to the breach in the first place. So we will try and predict how these breaches could have happened, what misconfigurations could have led to these breaches, and what you can do to prevent such misconfigurations on your network and thereby prevent security breaches. Right? Now, 3 reasons misconfigurations occur on your network. The first and the most simple reason is that your default settings are unchanged, right? I like to call these the dangerous defaults on your network. A good example of this is your local admin passwords. Right now, you have a network, you have many computers, you've used local administrator accounts to configure these computers. And the problem is, once you configure these computers using the local admin accounts, the passwords for these local admins are seldom changed. Right? They remain the same throughout their time in the organization. And once an attacker gets access to these local admin accounts, it's only a matter of time before he or she compromises a server and then moves on laterally to another server and eventually your domain controller. Right? The first reason misconfigurations occur is that the default configurations or the default settings in your network remain unchanged. Local admin passwords is just one example. Another reason misconfigurations typically occur in your network is because permissions are unrevoked in your network, right? Let's say your users have requested for admin permissions to install an application or to access a service, right? And you grant the permission, but then later you forget to revoke the permission. So essentially you've got users walking around in your organization with permissions that they do not necessarily need to have. The third reason misconfigurations occur is because of vulnerabilities with platforms. All platforms like Active Directory or Azure Active Directory or Windows ecosystem or even Amazon Web Services in general, they have certain vulnerabilities, right? It's software. Software has vulnerabilities. And if these vulnerabilities are not fixed or are not covered in time, attackers will leverage the vulnerabilities that come with these platforms to again gain access to your network, thereby compromising your company data and also the privacy of your employees. Right? So these are the top 3 reasons: default settings that remain unchanged, permissions that are given to users but are unrevoked, and last but not the least, vulnerabilities that come with platforms. These are the default vulnerabilities. Right? So let's take a look at various misconfigurations that led to devastating breaches in 2020. And I'd like to start off with a simple example. Right? Now, do keep a look on the top right corner of your screen where I will be mentioning if the reason for the breach is a misconfiguration or a system vulnerability that attackers have exploited. Right? So on December of 2019, Microsoft realized that it was breached where one of its Elastic database servers were breached and around 250 million customer support records were exposed or leaked. Right? Microsoft released a notice for the breach that the breach had occurred on January 2020, and Microsoft claimed that the reason for the breach was a misconfigured security group or a misconfigured network security group that gave attackers unauthorized access to a database server. Right? The most recent breach occurred in 2021, just last month, where SolarWinds was compromised. Right? So this breach started around December of 2020, but eventually SolarWinds was able to discover that it had been breached on January 2021, and this happened because attackers got access to an Office 365 account, and eventually the attacker was able to move from one compromised Office 365 account to another, thereby compromising the SolarWinds products in many organizations around the world that have used SolarWinds. All right. Now, before we begin, I'd like to tell you that the SolarWinds investigation is still undergoing. More and more reasons for the breach are being uncovered. But for now, the major cause or the major misconfiguration that led to the breach was a compromised Office 365 account. Right. Now, let's take a look at these breaches in detail. Let's take a look at the behind the scenes of these breaches, and let's observe how these breaches can happen to you or can happen to your organization. Right. So, how could the SolarWinds breach happen? How could an Office 365 environment or an Office 365 tenant in an organization be compromised? Right? It's pretty straightforward for an attacker to compromise an Office 365 account because discovering Office 365 emails is very, very simple. Right? If you click on this particular link right here, it will take you to my article that will show you the various ways emails can be discovered, right? Corporate emails, Office 365 emails, Azure AD emails. And I'd like to stop this by saying that there are many, many ways attackers can discover emails. There are free open source tools on the internet that can help you discover emails. There are tools that can help you draw combinations for emails based on the name that you've given into them. You can discover emails based on weak naming formats. You can use social engineering tactics to extract emails. My point here is that there are a lot of ways an attacker can discover emails, right? There could be Office 365 emails. There could be emails to your AWS instance. There could be emails to your Azure instance as well. And once attackers have discovered emails, the next step is to try and compromise the account holders of these emails. Right? Now, how that could happen is with a simple password attack that I will be showing you right about now. So as you can see, I am on my VM and I'm logged in as the administrator, right? But this attack that I will be showing you can be performed by any user in your organization. I repeat, a non-privileged user can launch this attack on your infrastructure. So I'm on the desktop, I'm logged in, and I have a script here that basically says misconfigured, right? So here's what's going to happen. I will import the script. I'm going to say import module, just a straightforward PowerShell script, nothing fancy happening here. msolspray.ps1, the script has been imported, and I will run a command called invoke msolspray, and I will give in a list of usernames. So here I have a text file with a list of potential email addresses that an Office 365 tenant in an organization holds. Like I said, there are many ways with which you can discover email addresses. Free tools on the internet can help you with this. And here I have a list, and here's what I'm going to do. I'm going to give in the name of the text file that we just saw. That's userlist.txt. And I will give in a very predictable password. Let's just say password at 123. Right? And once I hit enter, you can see that just within a few seconds, the spray has started. And let's give it some time, right? We've got users and their passwords right in front of us. Right? Now note that the password is expired, but that doesn't matter. We can always change the password of the compromised user, thereby locking out the user from their account in Office 365. Now, please note that as an attacker, I have unlimited capabilities to perform this attack. I can discover email addresses, and a simple PowerShell script, I was able to launch a password spray attack on an Office 365 environment or on an Azure environment, right? And this attack, I repeat, can be performed by your standard users, your users that are not privileged. Right? So that's how the SolarWinds breach started, because attackers were able to get a hold of an Office 365 account and then were able to leapfrog from one Office 365 account to another. And this is how the attack could have happened. Right? Now, how could the Microsoft breach have happened? Right? Like I said, Microsoft faced a security breach where a misconfigured network security group on a network basically gave unauthorized users access to Microsoft's database servers. Right? How can groups be misconfigured? Let me show you a simple example again. Right? I'll open up my browser, and here I have an attack that I recently created and I've uploaded on our channel. And this is how the attack works, right? I have a simple PowerShell script. And here's what I'm going to do. I will import the script on a PowerShell session. Please note that I'm logged in as a user called Ross, and Ross has absolutely no privileges. Again, a non-privileged user. And once I've imported the script, I'm going to run a command called invoke all checks. And once I do that, I'm going to run a command to basically install an application onto Ross's desktop or Ross's instance, right? You see this application right here. It's called user add. Right? This is an MSI application, and this script is again power up. It's freely available on the internet. You can just Google it. You'll have the script right in front of you. And what does the application do? The application, as you can judge from the UI, is going to add a backdoor user to any group in Active Directory. That's right. It could be an admin group. It could be a privileged group. And this application will help you gain backdoor access to Active Directory by adding the user to the group that you wish, right? So I'm trying to add a backdoor user to the administrators group. I hit create, and let me show you what happened here. You see this? This is the administrators group, and here is my backdoor user, right? So what just happened here? How could a non-privileged user simply use a script to drop an application and then leverage the application to add a backdoor user to an Active Directory group? And just to refresh your memory, this is how the Microsoft attack could have happened as well. A misconfigured security group gave unauthorized users access to a database server. And this is how this attack could take place on your environments. An attacker could simply execute a script, add a backdoor user to any Active Directory group. Right? Now, the reason this breach happened, I'm letting out the secret here, is because this particular setting that you see, always installed with elevated privileges, was enabled on my network, right? So what does this particular group policy option do? This allows your users to install applications, right, under local admin or under system admin privileges. Now, what do I mean by that? Now, do you see this option? This is enabled on my network, right? Always installed with elevated privileges. And when we get back to the attack, you will notice that the attacker was able to run the application, right? And the application almost instantly opened up, right? Now, the reason that happened was because this group policy option was enabled, always installed with elevated privileges, and that gave the user the ability to run the application that you see right here, under admin context or with admin credentials, right? Had the group policy setting be disabled, if this particular group policy setting was disabled, then the application, when run, would have prompted for admin credentials. But unfortunately, the organization had the group policy setting enabled, and the user was able to run the application with admin credentials and thereby add a backdoor user. Right? So as you can see, I am sure you're trying to connect the dots here. Every breach happens because of misconfigurations on your network. Right? In this case, the misconfiguration was a misconfigured group policy setting. And in the previous attack, the misconfiguration was weak passwords and the ability of users to run scripts to compromise the weak passwords. Right? These are the misconfigurations that led to these breaches, right? Let's take a look at another example. A Japanese telecommunications company, NTT, was subject to an Active Directory server hack where its Active Directory domain controller was compromised. Right? Now, how could this happen? This attack was pretty straightforward. An attacker compromised an endpoint in Singapore, and then the attacker was able to move from the endpoint to a server called server A that is in close proximity with the AD server or the Active Directory domain controller, right? So endpoint was compromised and the attacker was able to move laterally to an internal server in close contact with an Active Directory domain controller, and the attacker was eventually able to compromise the Active Directory domain controller. This is how the NTT Japanese telecommunications company was hacked, and more than 600 employee records were leaked out or were exposed in the attack. right? Now let's take a look at this attack in detail. Let's take a look at the behind the scenes, and let's observe how this attack could happen to you as an organization, right? So Active Directory is a prime target in most attacks, right? I'm sure most of you attending this webinar right now have Active Directory as your authentication and your authorization mechanism in your organization, and rightfully so, because Active Directory has been around for many, many years now, right from the year 2000. Your workstations, your member servers are all managed in Active Directory. Your group policies or your security policies are governed in Active Directory. And the truth is, because Active Directory has been around for a long, long time, attackers have started to figure out ways to compromise Active Directory. And that's what happened in the NTT server hack, right? Now, how could this attack have happened? Like I said, a very, very typical Active Directory attack where the attacker started from a compromised endpoint and was eventually able to compromise the domain controller and gain complete domain dominance, right? So let's take a look at how this could have happened in your organization. Right. Now, the initial step in most Active Directory based attacks is to compromise your endpoints, because endpoints, they typically have weak security regulations. Endpoints have no privileged access, but an endpoint access is all an attacker needs to move laterally to another server, a privileged server, or even a domain controller, right? Here's a simple example as to how this attack could have happened on your network, right? An attacker could launch a simple phishing email on your network, and with the phishing email, the attacker may convince the user to install a keylogger script, a backdoor keylogger scripts, capture user credentials, and thereby compromise the endpoint, right? Let me show you a simple example right here. If I open up my browser, do you see this email? This email is to Thomas, and here's what the email reads, right? So it says, good morning, will you be in office today? Please find attached a copy of the termination list for this month. I'm very sorry for that. You will get your 2 weeks payout. What time can I call you? Right? Now, I'm going to let out a secret here. This was a ransomware email that I had received back in 2020. Just when COVID started, an attacker thought it would be fun to compromise my computer and sent me out this email, right? And what does the email have? A termination list. And as a curious user, we will try and download and see what is in this termination list because, well, it's scary, right? So as soon as I open the termination list and I click enable content, you will see that there's nothing in the list, but then a calculator has opened, right? So why am I showing you a calculator? Why am I showing you an application and a Microsoft Word document? Now, the reason I'm showing you this example of an attack is because this is how most attacks happen on your Active Directory endpoints, right? An attacker starts off with a phishing email, as you can see right here, and curious users will try and download the document that is attached within the phishing email. And once the document is downloaded, the user sees that there's nothing in the document, but little does the user know that there is a backdoor malware or virus that has been installed by the attacker. In this case, it happened to be the calculator for an example, but it could be anything else. For example, a keylogger attack, right? So user clicks on the malicious email and a keylogger is installed on the desktop that reads everything a user types, right? Like entering a remote session or passwords typed by the user, and these credentials that were entered by the user, that were recorded by the keylogger, are sent back to the attacker's system. This is a very, very plausible scenario because, like I say, in every attack, everything starts with the click. And in this case, it started off with a phishing email. And within a few moments of time, an attacker can basically compromise an Active Directory endpoint. Right? Once an endpoint is compromised, what could be the next step? Right? Let's say an attacker has launched a successful phishing attack and then the attacker has compromised the endpoint in the organization. What could the attacker do next? Because the attacker has to move laterally from one server to another, right? And eventually compromise the domain controller. So with initial access obtained to an endpoint machine via a phishing email, the attacker could launch a password brute force attack on Active Directory accounts. Right? This is how the attack would work. Let me quickly show you an example right here. Here you go. What you see right here is a script on your screen that basically attacks the Active Directory administrator account with 100 passwords that is in a text file, right? So the script is pretty straightforward, just a standard PowerShell script. We are targeting the administrator user. This is the name of the DC. And here you go. Here's the text file with a list of passwords, right? And once the attack has started, you can see that various passwords will be tried on the admin account. And just within a few seconds, we have the admin's plain text password right in front of us, right? Again, a simple attack, but still widely used in most organizations. And the important thing to remember here was that the admin account was targeted in this attack, right? Why are we targeting the admin account? The reason for that is because admin accounts in Active Directory have no lockout policy, right? Now, I'm pretty sure all of you using Active Directory have heard of the lockout policy. There is a lockout threshold on your organization, right? For example, if a user enters an invalid password or an invalid username for more than a fixed number of times, the user's account would get locked out, right? But unfortunately, a little known secret is that the Active Directory administrator account has no lockout policy. This is the most powerful account in Active Directory, but it has no lockout policy, which is why it is a prime target for most brute force attacks, right? So here, this is what happened so far. We've compromised an endpoint with a phishing email. We've captured credentials to the endpoint. We've logged on to the endpoint, and we've launched a brute force attack on the Active Directory administrator user, right? So here we have a compromised endpoint and eventually the administrator's credentials, right? Now, how else could this attack happen? An attacker from the endpoint could survey your Active Directory environment for any details, right? So this is a system vulnerability. If you take a look at the flag on the top right corner of your screen, and the reason I call this a system vulnerability is because this is how Active Directory is designed, right? Any user, even a non-privileged user, can simply log on to Active Directory and query for details like get AD default domain password policy. Here's the password policy of the domain. And here you go. These details can be queried by a user with no privileges as well. And these details are extremely useful because then using these details, I can plan a password spray attack or even a password brute force attack on my organization, right? The list is innumerable. For example, I can get the details, right, of an administrative group within Active Directory. So I'm going to say identity, and I am going to give in the administrators group right here. Here we go. And once I click enter, I will have the details of all the administrator users in the administrative group in Active Directory, right? So what's my point here? What am I trying to show here? Let me quickly show that to you. Get AD group member identity administrators, and once I enter, here I have a list of all the administrators that belong to the administrators group, right? So an end user can simply log on to an endpoint and search for Active Directory critical information, right? So if the brute force attack had failed, what I could do is I could search for users that I'd like to target in Active Directory. I can search for privileged servers. I can search for shares that I could potentially access. I can search for any databases that I could compromise, right? So this is also possible from an endpoint, and this is a system vulnerability because this is how Active Directory is designed. Any authenticated user can query for information from Active Directory, right? So where do we stand right now? We've compromised an endpoint via the phishing attack, and from the endpoint, we were able to traverse to a server A, right? Now the actual attacker compromised the endpoint and moved to a cloud server and eventually to server A and compromised the Active Directory domain controller. But since we are trying to understand how this could happen to you as an organization, let's move from the endpoint to a critical server or server A, right? So there are two ways this could have happened: endpoint compromise using the phishing attack, administrator account access using the brute force attack, or once the endpoint is compromised, right, an attacker can simply generate a dump file using the task manager. Right. So it's pretty straightforward. With access to the endpoint, I can launch my task manager application. Right. I can head into details. I can look for the LSASS process and I can create a dump file. Right. There you go, create dump file option. What does the dump file have? The dump file in Active Directory environments typically has the credentials and the passwords of all your users in Active Directory. So this is how a dump file looks like. Right? And what can an attacker do with the dump file? The attacker could take the dump file and take it back home to his own system and basically extract the dump file to get access to the plain text or clear text credentials. This dump file can be, the plain text credentials can be extracted from this dump file by using tools like mimikatz. Right? So just a straightforward attack. An endpoint was compromised via a phishing attack, and the attacker simply generated a dump file and then used the dump file to get access to credentials that are stored in the dump file, right? So these are credentials that are stored on the local memory of your endpoints, right? So why are credentials being stored on the local memory of your endpoints? This could happen for various reasons. For example, if this particular option is enabled on a computer, trust this computer for delegation, any user who ever logs on to the endpoint or the computer, his or her credentials will be saved in the local memory, right? It could be a remote access, it could be an interactive logon. No matter what the logon is, those credentials will be saved in the local memory, and an attacker can extract the credentials by creating a dump file and later acquiring the credentials from the dump file by using tools like mimikatz. Right? Now, access to the AD server. We've seen many ways how an attacker could compromise the endpoint and how the attacker could move from the endpoint to the server A. Right? A phishing attack we started with, and then we performed a brute force attack. We tried to query for sensitive Active Directory information, and then we tried to generate a dump file from the endpoint to gain access to the credentials that give us access to a privileged server. And here we are finally, right? Because we now have access to the admin account via the brute force attack, we could directly log into the domain controller, right? Or the dump file that we generated could have domain admin credentials using which we could log on to the domain controller as well, right? Or you could promote the endpoint as a rogue domain controller. So what is a rogue domain controller? An attacker basically promotes the compromised endpoint as a rogue domain controller to inject backdoor changes into Active Directory. And once backdoor changes are injected, the attacker unregisters the rogue domain controller. Right? So as you can see, attacker registers the rogue domain controller, and attacker sends changes to the backdoor Active Directory object. And then once the changes are sent, the attacker unregisters the rogue domain controller. Right? This is another way an endpoint can be leveraged to inject backdoor changes. For example, the attacker could inject the administrator SID or SID 500 to a user account, right? To a backdoor user account. So this is how the attacker could move from the server A to a domain controller, right? Or an Active Directory domain controller. This is how the first attack or the NTT attack could have happened. Log360 can help you detect such intrusion attempts, because Log360 can help you monitor such changes. right? Any security group changes, like the first attack we spoke about, where a group gave access to Microsoft database servers. Any group policy changes that allow attackers to install malicious applications, right? Any scripts that are run on your network to create malware, right? To create a phishing email, right? So like I said, the malicious script that we just spoke about here, the document that I just showed you here, could also be created by a PowerShell script, as you can see right here. This is a malicious macro creation using a PowerShell script. This could happen as well. So if such scripts are invoked on your endpoints, this is something you need to detect, right? Or if scripts that are used to perform password spray or brute force attacks are run on your environment, you can detect such scripts as well, right? Or if attacker is trying to dump password or create a dump file from the local memory, you can detect those changes as well. Or if an attacker decides to register a rogue domain controller to promote the endpoint to introduce backdoor changes into Active Directory, you can detect those changes as well, right? Log 360 can help you with all of these changes, security changes on your network, right? So that's the first attack. We were able to compromise the endpoint, as you can see, and then we were able to move to a server A by various attack methods that we discussed, and finally compromise the Active Directory domain controller. Right? The next attack I want to talk about was simple ransomware attack attempts in 2020. 2020 was the era of ransomware attacks because we all started working from home, lesser security controls, and that's how ransomware attacks begin in organizations. And every ransomware attack follows a similar pattern which can be detected by Log 360. For example, exposed remote desktop credentials may give an attacker the initial access. Once remote desktop credentials that are exposed are obtained by the attacker will disable communications on your network, meaning the attacker could shut down the firewall, any backup processes, or any security or monitoring processes. Right? Then the attacker will start encrypting your files or folders, and finally the attacker will lock down your files or your data on your network and demand ransom from you, and only when you pay the ransom will you receive the decryption key to access your locked out data. Right? This is how most ransomware attacks happen, and the snake ransomware attack was something that was very, very prevalent back in 2020. Right? Companies like Honda were subject to this ransomware attack, where Honda had to shut down its operations for more than a whole month. Right? This attack happens because of insecure remote desktop credentials. If your users are accessing your servers remotely from a public Wi-Fi, they could be subject to a man-in-the-middle attack. And once the remote desktop credentials are obtained by the attacker basically disables all the services on your network. Right? This is a targeted ransomware attack because attacker already knows the credentials before he attacks your organization. And the attacker, as soon as he acquires the remote desktop credentials and logs on to your network, tries to kill all your backup copies, tries to kill a list of hard-coded processes like your Windows backup processes or Windows event log, event viewer, or any security process that is running on your system. The attacker will then disable all the firewalls on your system. The attacker makes WMI calls to other nodes on your network, thereby disabling firewalls and disabling all backup and deleting all backup processes across all the nodes on your network. Right? And then the attacker installs a simple file, introduces a file onto the syswall on your domain. Right? Syswall is responsible for the group policies on your domain. Right? The syswall folder is used to basically propagate group policies that you've configured on your domain controller to other endpoints on your network. Right? Attacker introduced the malicious file onto the syswall folder, and using which the attacker was able to basically propagate the ransomware across every node on your network. Right? That is how the snake ransomware attack happened. Similarly, if we speak about the coronavirus ransomware attack, this is how it happened. Right? A similar fashion, the coronavirus ransomware, instead of entering via insecure remote desktop credentials, it enters or it infects your organization via malicious updates like your Flash Player update or malicious ad malware or advertisements. And once it gains access to your network, it registers itself inside the registry, inside the run key of your registry, right? And then just like the snake ransomware, it deletes your backups and your shadow files, it disables your firewall, etc. And then it will start encrypting your files with this extension, right? So like I said, ransomware attacks follow a similar fashion of attack. An initial point of entry, like a malicious advertisement or an update or exposed remote desktop credentials. And as soon as they gain entry, they disable your services, like your backup services, your security services. And once that's done, they establish themselves they establish a foothold to spread to every other node or every other workstation or endpoint on your network. So Log360 can help you detect ransomware attack attempts, because most ransomware attacks happen via scripts. We can read into the script data and detect any malicious scripts that are being run on your organization, right? So if I open up AD Audit Plus, a component of Log360, and head into server audit, right? Do you see this report called PowerShell auditing? This will help you detect any malicious scripts that are being run inside your organization. Right? It could be a brute force attack. It could be a password spray attack. It could be a script to install, to create a malicious attachment to compromise users in a network, right? An attachment like this that I just showed you. Right. So AD Audit Plus can help you detect all script executions. It could be ransomware. It could be an intentional attack by an end user or a compromised user account. You can always detect the scripts. You can read into the script data, meaning you can understand what exactly is in the code of the script. And of course, you can configure alerts where you can alert the authorized admins via email and via SMS. Right? These alerts are extremely customizable. You can configure alerts based on a threshold. For example, if there are more than 10 logon failures in your organization occurring within a minute, then alert the admin. Right? If an end user is running scripts outside of business hours, then alert the admin. If the script data or a script code or the code block inside the script has so-and-so code, then it could be malicious. So alert the authorized users. So Log360 can help you detect ransomware attack attempts, because Log360 can monitor services that are being shut down by ransomware attacks, new services that are being started. For example, the nmon.exe process that is started on servers whenever snake ransomware attacks your organizations. Any registry key changes, because the coronavirus ransomware, for example, registers inside your network under this registry key. So you can monitor those changes. Any changes to your critical system files and folders, like your sysvol folder, because like I said, this is how the snake ransomware attacks propagates inside your network. All such changes will be brought to notice. And last but not the least, file or folder modifications, right? Once a ransomware attack gains access to your network, disables all the services, it will encrypt all your files and folders, and it will then rename them, right? And Log360 can detect abrupt file or folder modifications, not just across your domain controllers, but across all the endpoints in your organization. That includes your workstations, your workgroup machines, and even your member servers. Right? You can build correlations to detect ransomware attacks in your network. Right? This is an example of a snake ransomware attack detection, where you can set up actions and you can combine those actions, and you can create an alert using Log360. For example, if a file is created, if so-and-so processes are killed or created, if the files are renamed, you can combine all of these actions and generate an alert for ransomware attack attempts on your network. Right? Now, I wanted to speak about a few default vulnerabilities in Active Directory, and this is one such example that occurred back in October 2020. This is also known as the zero logon attack. Right? So what is the zero logon attack and what does it do? I have written a blog on it, so you can quickly head on to the blog. I'd be more than happy to share the link with you to learn about the zero logon attack. And this is how the zero logon attack works. Right? Now, generally in Active Directory environments, client systems have to authenticate with a domain controller. Right? Now, I do not wish to complicate this further, but in this particular attack, there is a flaw within the authentication protocol, when a client system authenticates with the domain controller, and the attacker was able to send null passwords, right, to log on to a server and thereby authenticate to a domain controller, right? So a client system generally authenticates with a server by using a handshake process, like you can see here. Client challenge is sent, a server challenge is sent, a session key is created, etc. And in this attack, an attacker was able to send a client challenge that has nothing but zeros. And the baseline of this particular attack is that the attacker could impersonate any server on the network by logging in with a password that consists of nothing but just 0, 0, 0, 0, right? An attacker could impersonate any server, including your domain controllers on your network, by just logging in with an empty password, because there was a flaw within the authentication protocol on Active Directory networks, right? This was a zero logon attack. This was pretty notorious back in 2020. Now Microsoft has released fixes for this attack, but if you'd like to detect such attack attempts on your network, we can help you with that, right? So we can help you detect such attack attempts because we let you monitor certain logon attempts. For example, any logon on your network with event ID so-and-so and has the target name anonymous logon could be a zero logon attack attempt. And if I head into AD Audit Plus, head into reports, right? Do you see user logon reports right here? And do you see logon failures or logon activity based on a DC or member server logon activity? Using these reports, you can basically zero down logons on your network, and you can detect logons that have a particular event ID or even a particular username, right? So in this case, if the username happens to be anonymous logon, if there's any username like that on your network, it could be a zero logon attack attempt, and we can help you detect such attacks. So this is an attack where an attacker can impersonate any server on a network by just giving a password that is 0000. And in order to overcome this attack, Microsoft introduced a new group policy setting called Allow Vulnerable Net Logon Secure Channel Connections. And what this does is it allows you to specify the systems, right, that are authorized to use vulnerable net logon secure channel connections. Right? Now, for example, let's say you have a Linux system in your organization, or let's say you have a Unix system in your organization, right? Basically a non-Windows system, right? So the patches released by Microsoft will not apply to your non-Windows systems, correct? So these non-Windows systems can still be used in the zero logon attack, where an attacker can use a Linux system to basically log onto your network with nothing but a bunch of zeros as a password. And in order to overcome that, Microsoft gave you this particular group policy setting to set all your non-Windows devices that are allowed to use vulnerable net logon connections, right? So if you have an authorized Linux system, you can configure the system right here, and then it will be allowed to use a vulnerable net logon system or net logon connection, and the connection is authorized because you've registered the system in the group policy, right? Now, this may be getting a little technical, but just know that using this attack, an attacker could impersonate any server in the organization. The first thing I would encourage you to do is to download the patch that you see right here, right? This will lead you to the patch and install it on all of your domain controllers in your organization. And to detect zero logon attacks on your network, I would encourage you to monitor the logons, right? For example, you see this option right here, event ID 4624 with anonymous logon. If you find such logons on your network, do check into it or do look into it, because it could be a zero logon attack attempt, right? And last but not the least, the group policy setting right here, ensure that only authorized devices are allowed to use a vulnerable connection, because if there is an unauthorized device here, the attacker could leverage the unauthorized device to again gain access to your network with null passwords, right? Another vulnerability that occurred just a month ago was the Linux sudo vulnerability, where there was a vulnerability on Linux systems where an end user, I mean a non-privileged user, could run commands with the root administrator privileges, right? Sudo only administrators can run, but there was a flaw on Linux systems using which an end user could execute the sudo commands on your network. There is a patch released for it. Do download it, and Log360 can help you detect such problems as well. Because if I head into Log360, right, so I'm just going to open up component of Log360 called the event log analyzer, right? If I log on to the event log analyzer, quickly jump into reports, and you see these reports called Unix or Linux reports, right? And if I come down, do you see sudo commands? Whenever sudo commands are executed on your Linux systems, you can detect those commands, right? Because there could be a vulnerability on your Linux systems that is being leveraged by your attackers. This is a sudo vulnerability. So any sudo command executions, we can help you detect that as well. Right? And similarly, for the zero logon attack, we've also offered a report right here that basically says net logon vulnerable channel audit. So like I said, any system that is allowed to use a vulnerable connection, an attacker could leverage, right? So you have to ensure that only authorized systems are allowed to use a vulnerable net logon connection. And these reports right here will help you capture whenever there is a vulnerable net logon connection used inside your network, right? And so you can ensure that only authorized devices can use a vulnerable net logon connection and not an unauthorized device or an attacker's device. Finally, we've got one attack, that's the Twitter privilege abuse security attack. This occurred back in July 2020, and I'm pretty sure you would have heard of this, where an attacker targeted about 130 Twitter accounts, and cryptocurrency scams with messages like so that you see on your screen were put out for the attackers, by the attackers, from various celebrity accounts like that of Elon Musk or even Samsung or Apple, etc. And this attack happened because of two reasons, right? Basically, this is how the attacker was carried out. An attacker was able to compromise a bunch of internal users who had access to a Twitter's privileged server, right, or an admin server. The hacker somehow got the credentials from these internal users, and then the hacker accessed the admin tools and basically reset their passwords and pushed out cryptocurrency scams from those accounts. Right? So there are two mistakes that happened here. Number one was that the employees had broad access to the admin server. There were a bunch of employees inside Twitter who had broad access to the admin server. This shouldn't be the case in your organizations, because only authorized users must have access to the privileged server, right? That was the first mistake that happened. The second mistake that happened was accesses to the admin server by the attacker were not monitored, right? So that's two mistakes: broad access to the admin server and administrative activities, meaning whenever the attacker tried to log on to the admin server and perform changes like resetting passwords of the Twitter accounts, all of these changes were not monitored, right? And this is something you have to monitor in your organizations. You have to ensure that broad access is not granted to your users, because if just in case any of these user accounts are subject to an attack, these accounts can be leveraged to gain access to your privileged servers. And the second thing that I would like for you to monitor is any accesses to a domain controller, to an admin server, or even to a privileged member server must be monitored. These were the mistakes that Twitter did. Employees had broad access, and any changes occurring on the admin server were not monitored, right? For example, passwords were reset for accounts in Twitter. The admin server was logged on to from an unknown source, meaning from the attacker's system, from an IP address that is not a part of the organization, right? And changes such as that were not monitored. And that is what, ladies and gentlemen, led to the hack, when an attacker was able to push out cryptocurrency scams from famous accounts like that of Elon Musk or even Apple or Samsung. Right? So Log360 can help you with all such activities, because Log360 can monitor your Active Directory, your Azure environment, your file servers for changes. It can alert the authorized users on changes and not just alert. Log360 is also capable of executing remedial actions. Right? For example, let's say there is a password spray attack on your organization. And the threshold-based alerts, you've set a threshold saying if there are more than 10 logon failures occurring in under 2 minutes, it could be a password spray attack. So alert the authorized users via email and via SMS, and not just that, execute a script. What does the script do here? The script kind of functions like a remedial action to the generated alert, right? For example, if there's a password spray attack, the users will be alerted, and the script right here will terminate the attacker's session, will shut down will disable the user account that is being subject to the attack. Right? Similarly, if there are any security group membership changes occurring outside of business hours, this could be a backdoor group change that is not authorized. So the users can be alerted, and a script can be used to disable the account that is performing the attack. Right? There are various alert profiles right here that you can leverage out of the box. You needn't waste time building it. For example, if I search for admin, you see this? Modified admin groups. Whenever admin groups are modified, you will receive an alert. Whenever there are logon failures on your admin users or for your admin users, you will receive an alert. Right? And Log360 is capable of going back in time. So you see the reports here, you can go back in time and check for changes. And if you have multiple domains, you can check them for changes as well. And now we understand that most of you are adopting Azure AD. So we support Azure AD as well. And of course, multiple tenants in Azure AD as well, right? So your Azure AD, your Active Directory environments, your file servers, all of them can be audited by Log360. And Log360 can also audit all processes that are native to your Windows or your Linux systems, right? USB device plugged in, a new process started, firewall changes, your Hyper-V machine disk changes, any Linux yum installs or a sudo command run on your Linux system. All of these changes can be audited, right? So that is about it for today. A quick summary of what we saw in today's webinar. We took a look at various attacks, right? We took a look at the Microsoft breach. We took a look at the SolarWinds breach. We took a look at the NTT security breach. We took a look at ransomware attacks. We saw the Twitter account hack, and we saw some default vulnerabilities, some CVE vulnerabilities that were leveraged. And we saw the behind the scenes of these attacks. We understood how these attacks could happen to you or your network, and we were able to build a defense using Log360. So do check out Log360. The two major tools featured today were AD Audit Plus and Event Log Analyzer. Both of them are a component of AD360. AD Audit Plus basically helps you audit your Active Directory, Azure environments for changes, basically all your objects in there, can help you audit your file or folders for changes, can help you audit your member servers, etc. And Event Log Analyzer gives you in-depth auditing capabilities based on your Windows systems. For example, if there are registry keys that were changed, right? If there are any Windows critical reports, like a service that was started or a service that was stopped, all of those changes can be detected by Log360, right? Your Windows, as well as your Unix and your Linux systems as well, can be detected, all right? Both of these components, AD Audit Plus and Event Log Analyzer, are a component of Log360. And once you purchase Log360, you can access both of these components from a single pane of glass, like you can see I am doing here. All right, so here you go. Here you have AD Audit Plus, and here you have SIM, or Event Log Analyzer. Right? Now, before I end today's session, I would like to thank you all for your time. I would like to thank you all for your attention. I hope you found the session informative. There's a lot we looked into today because honestly, there were a lot of breaches that occurred in 2020, and truly understanding why these breaches have happened is extremely difficult, but we did attempt to understand it. And before I end this session, I would like to tell you that this is a new creative that we worked on, right? So all the attacks that I showed you today or that I explained today can be viewed hands-on from this page. So the technical attack will show you actually how the attack happened, and the attack flow will help you understand the flow of the attack, and the solution will help you build solutions using Manage Engine Log 360, right? So any attacks that you saw today will be present in this page. I will quickly drop a link to the page to you using the chat window. So do check it out. Do check out the attacks. And using which you can understand how attacks occur on your organizations, and you can also understand how Log 360 can be of help. So thank you for your time. Thank you for your attention.